Assalamualaikum warahmatullahi wabarakatuh. And a very good morning. My name is Mama Hafiz bin Mama Amri, and today my group is going to present on a topic about our project regarding the paddy fertilizer spraying. Our project is about making a functional trolley that helps to spray fertilizer uniformly. We are motivated to make this project because we are hurt to see that some farmers, they have to go through such burden of carrying a bag of fertilizer weight 20 kilogram every day to the paddy field. That will cause them back pain and will make them will spend a lot of time in the paddy field every day. The main problem that we are solving right now is the non-uniform spread of the fertilizer. And our intended targets are for the small size paddy farmers. And what the impact of this problem toward our user is that it will cause low quality products of the paddy field harvested at the end of the season because of the uniform spread, non-uniform spreading. And why the problem is worth solving is because when the paddy field is not at the top quality, this will definitely affect the farmer's income because the farmers depends highly on the quality of the paddy field when they harvested at the end of the season. And for the design specifications, we have three objectives that we are trying to achieve. First one is to provide uniform spread, and the characteristics that involve with it, distance and speed, and also the amount of fertilizer per area. And the second objective is to make sure that our product, it can provide ergonomic function, which is to reduce back pain. And the characteristic that relates to this are the pushing angle of the handler, which is 60 degrees, and also the height of the trolley itself. And lastly, our objective is to reduce the time taken for fertilization, which is we estimate that we can target 0.5 hour per acre. And our solution, this is our full sketch of our prototype and how our solution with all the enablers involved. And how our solution works is that first we can put the fertilizer in this tank, and the fertilizer will drop automatically to using the inclined plane to both nozzle valves. And then when we press the throttle will control the opening of the valve. So when we press the throttle, the valve will be open at the maximum rate, and the fertilizer will drop down to each line of the paddy field. That's basically how our solution works.
Okay, for design analysis, firstly, from the total weight that we had calculated, we get the total weight is 97 kilogram, and from the weight, we can calculate the force needed with the coefficient friction on the mud surface. So we get 599.49 Newton, and we calculate for the power needed, which is 509.57, and it is equal to 0.68 horsepower.
And our trolley, its height is 0.95, and to calculate the height of the handler, we use the maximum length, which is 1.6, and also the minimum length is 1.4. We are targeting this range of height for the handler, and then we minus with 0.5, which is the height of the trolley itself. Then we can get the maximum and minimum length 0.65 and 0.45 respectively. So we use the angle 60 degree to calculate the height of the handler, which is by using the Pythagoras theorem, we can get the hypotenuse length of the triangle itself.
Okay, for this one, we have calculated the amount of fertilizer needed in every valve. Cylinder goes through 1 meter at 1 meter per second. As we know that we have constantly moved the trolley at 1 meter per second. So the volume of fertilizer that usually used is urea fertilizer, which is 920 kilogram per meter cube. And we calculate the volume. So the volume is equal to 0.108 liter for every cylinder, and times it with 4, which is it has 4 valves because it's limited to 0.8 meter to the left and to the right. Okay, for the flow rate, we can calculate it and equal it to 1.08 times with 10 negative 4 meter cube per second. Okay, from the volume that we had calculated just now, we can calculate the height of the cylinder so that the amount of fertilizer is collected in that volume of cylinder, which is it has 2 different radius, and the exiting valve is smaller than the entering valve, which is 0.03. It is because to reduce the rate of the flow of the fertilizer to going outside the valve.
So the current existing solutions that exist in the market, we have discovered 3 of them, which the first one is the flowing method, which is easy to handle and no maintenance needed because it's human that throws it. But it can cost time consuming, very big. And also the volume that we can spread the fertilizer is also very small. And then secondly, we use the fertilizer spreader, which is the disadvantage. We can spray in a high volume capacity, and also we can increase the area, the covered area for our spreading. But its disadvantage is that it's heavy to carry for the farmer, and this will cause back pain to the farmer itself. And lastly, the newest technology is using the drone technology. Advantage is low time consumed, but also it can cover lots of areas. But its biggest disadvantage is it must be it costs high maintenance, and also it needs high cost so that we can get by the product itself. So that's all from us. Thank you.